Hello, I've decided to do a fast example of stratification, both using R to directly compute the confidence intervals and then use the bootstrap. So suppose we have the following situation. We have a population, it's population size 2200, and we have split it into two strata. Strata 1 has 800 units in it. Remember, this is completely arbitrary. And strata 2 has the rest, which is going to be 1400. Let me make sure I can do basic math today. Oh, by gosh, I can. So this is the idea. We take a sample of size, let's suppose we've taken a sample of size 10 out of the first population. The first strata, I should say. And let's say this is the strata right here. Or the sample right here. So we've taken 10 things from the first stratum, and we're reading them into a variable called sample1. And then we're going to have 9 things in sample 2. So we actually have a sample of size 9 from the second sample. By the way, I could always look at the lengths of these. Sample 1 is 10. Length sample 2 is 9, and so on. Look at their means and variances and so on. But instead I'm going to go use the usual estimator. So let's look at the proportions of each one. So the size of strata 1 compared with everything is 36%, and the size of the second strata is 63%. Okay, that's the 800 over 2200 and 1400 over 2200. So when we make a estimator of the overall mu, it'll just be weighted. So it'll be W1 times the mean of sample 1 plus W2 times mean. Now I'm not estimating a total, I'm estimating a mean, overall mean here. Okay, the overall mean I get is about 17.6, and that's my estimator. Now I need a variance for it. The variance is just going to look like, it's going to be W1 squared. I'll have my finite population corrections, which actually won't do much, but hey. Variance of sample 1 over N1. And basically the same term, but all for the second strata. So it's going to depend on the relative size of that strata. It's going to have its own finite population correction, which won't do much in this case either, because they're pretty big strata. I get that. Oops. Where did I have an extra parenthesis? Oh, oops. Okay. The curse of the inserted parenthesis. Here we go. That's an extra parenthesis there and there. Okay. Now, I could look at the variance of mu hat, but I'd rather look at the standard error, which is square root of variance of mu hat. Standard error is about 0.93. Whoa, out of 17.6? That's not bad. Okay. So, our confidence interval, I'll just compute each part of it, is going to be mu hat minus 2 standard errors. So this is the classical one, and then mu hat plus 2 standard errors. Now, I didn't see any huge outliers. Look up here. Nothing really horrible in the, well, there's a 20 is a low value, 38 is a high value. Here's go from about 7 to 15. On the other hand, they aren't big samples, so they're sample size 8 and 10 and 9. So I might think, instead of a interval from 15.7 to 19.4, maybe I should bootstrap it. So let's watch how the bootstrap goes. What I'm going to do is calculate that mean estimate. This is the simplest type of bootstrap, sort of the classic. I'm going to go 10,000 samples. So I'll go from I in 1 to 10,000. This is going to make a lot of loops. And then I'm going to make a sample from the first sample. It'll be the same size, but it'll be, as usual, with replacement. Then I'll take a sample from the second sample. Boy, the word sample is showing up here way too often. Replace equals true. There we go. And finally, I'll take that resampled mu that I made. Up here I made a kind of initialized 10,000 slots all with NAs in them. But now I'm going to fill them in one at a time. And I'm going to use the old formula. It's going to be W1 times the mean of SAM1. So I'm essentially replicating the calculation of the stratified mean, but with these resamples. So that's going to be W2. You're probably going, why isn't he computing the variance? Well, I don't have to, because these resamples will have the variance in them. I'll just take the middle 95% of them. So there's W2 times mean of sample 2. I'll close it up. I'll wait till it runs. Ooh, that was fast. Let's look at the histogram. See how nice this resample distribution looks. Ooh, 10,000 of them. They're taking a little while. Come on. Oh, not bad. This is almost bell-shaped. It's sort of centered on this around 17, a little bit more than 17, which is pretty much 17.6, pretty much what the estimator was before. So, nice. So I'll actually now get my bootstrap confidence interval from it. So I'll use the quantile command. I'll take resampled mu, the lower 0.025 of it. Okay, that gives 15.87. And 975. All but the upper 2.5%. Oops, what did I do? I can't spell the word resampled apparently. Okay. 19. Look how that compares with the interval. So up here we use just the classic approach. Got an interval from 15.7 to 19.5. Here when we did bootstrapping we got about 15.8 to 19.3. They're actually very, very, very similar confidence intervals, so I don't really think they're that much different, to tell the truth. So I did the stratified sample 2 different ways, using the usual formula, and I used the bootstrapping approach. And notice in the bootstrapping I essentially took a sample from each. So before I had a sample from each strata, sample 1, sample 2, and then I took a resample from each strata of the same size and then combined them together in the mean. Okay, that's it. Bye.